To understand an entity, it's essential to understand its origin. Over here, we'll try to understand the origin of charge and how we formalized it. From ancient time, people experienced some common phenomena for which our present-day charges are the cause. These are the lightning we see in the sky, an electric eel which gives shocks when touched, and most commonly amber when rubbed with fire attracts light objects. The first account of amber was found in ancient Greek. Tales of ancient Greek explain this phenomena as an evidence of inanimate objects having a soul. There was no indication of anything like charge. This effect was termed as amber effect. In the 1500s, it was found that jade, diamond, and some other substances also showed this effect. People now were looking for an explanation for this phenomena. The first effective explanation was given by William Gilbert in his book De Magnete in the 1600s. Here, he coined the new Latin word for amber effect, electrica, that came from the word electron, which in Greek meant amber. Gilbert hypothesized that the amber effect could be explained by an effluvium that acts on other objects. From this, we can derive that these particles were massless, which indeed is not true, as we all know electrons do have masses. And secondly, there was flow or transfer of something. This was quite an influential theory. During the next few years, people understood that when there is exchange of electrical effluvium between substances, they tend to attract or repel some other substances. This gave the idea that the electrical effluvium or electrical charge that we now call it is an intrinsic property of every material, and there must be some quantitative sense that decides if a body attracts or repels. Stephen Gray, while experimenting with amber effect, or modernly termed as electrostatics, saw that the cork that protected the glass tube, which was being charged or electrified, also showed amber effects. On further experimenting, he showed that this effluvium or electric fluid could be transmitted over distances by conduction. He found that certain substances facilitated or hindered the flow of effluvium. The substance that facilitated the flow was termed as conductor, and the substance that hindered the flow was called an insulator. He later discovered the phenomena now known as electrical induction. This said that a body could be electrified even from a distance. Now we know that it's because of accumulation of one kind of charge on one side of metal due to the electrical attraction. This led to the foundation that followed the discovery of the Coulomb's law. Till now, it was found that there was a phenomena of attraction and repulsion. This led to the idea that there are two different natures of charges. It was seen that only in close distance amber could attract the small particles. This meant that the attraction decreased with distance. Mathematically, it turned out that there must be some force between these particles, and this force must depend on the amount of discharged particles, which was evident from the fact that more we rub amber, the better it attracts. Therefore, F is directly proportional to Q1 and Q2, where Q1 and Q2 are the charges in the two interactive bodies. Experimentally, it was found that this force is inversely proportional to the square of the distance. Coulomb now combined these to give the Coulomb's law: F equals k q1 q2 by r squared. This is more or less where modern electrostatic began. With more advancements in atomic theory, electron charge was discovered, and it was found that all charges are multiples of this electronic charge.